Hi! Welcome to DTA's first virtual MRSE video series. This video will highlight the growing significance of electronic warfare simulation and how a simple yet powerful concept of IQ data streaming from hard drives solves complex and costly emulation techniques. Legacy electronic warfare simulation systems require skilled operators in large rooms to house their equipment. And even though they are currently being revitalized by digitizing their hardware, they still require a lot of people and a lot of space. Meanwhile, legacy systems are being upgraded to double and even quadruple the number of emitters and signals that can be simultaneously transmitted. Most of these legacy systems rely on data files consisting of pulse descriptor words, or PDW files, saved on a recorder and containing the radar signal parameter for each pulse, together with its timestamp. Electronic warfare equipment testers, evaluators, analysts spend careers collecting, sharing, editing PDW scenarios that can reliably produce the expected threats with confidence. But those threat parameters represented in these PDW files and scenarios are undergoing significant change. The United States Department of Defense's Operational Test and Evaluation Office has year after year called for improvements in electronic warfare test and simulation and evaluations in the labs and ranges to increase the number of emitters and to quickly represent threats that can change in mere hours. So how is it that DTA is disrupting legacy simulation approach? Well, it's because we're based on streaming IQ waveform data from solid-state drives to the RF transmit units. This results into any waveform that can be mathematically generated, presented, ultra-long scenarios, unlimited number of emitters, and an open architecture that allows a user to specify any number of RF outputs, phase coherency, or independent tuning. This new approach to electronic warfare signal emulation is outperforming the competition. And we currently have two product lines, the MRSE 1000 for narrowband signals up to 80 MHz bandwidth, and the MRSE 5000, that's 500 MHz of instantaneous bandwidth. And later this year, we'll be introducing a third line with 1 GHz bandwidth. This technique is possible after 10 years and over $50 million in research and development to develop a commercial, off-the-shelf system that's designed from the board level up through software to stream data at astonishing speeds for recording and playback.